Barrier Islands are a special type of island that is common and important in Florida. Many people live on Barrier Islands, which you will learn is not a good idea. A barrier island can be defined as a low, elongate, sandy island, generally parallel to the coast and separated from it by a shallow body of water called a lagoon. In the photo above, which shows a section of a barrier island off of North Carolina, you can see all the way from the ocean on the left to the lagoon on the right. Notice that the island is quite low, with elevations commonly not exceeding 10 or 15 feet. Barrier islands commonly have a naked beach fronting the ocean and backed by dunes and a low, vegetated, marshy backside that grades into the lagoon. Barrier islands are found all over the U.S., especially on the passive eastern margin. Some of the most famous are the Outer Banks of North Carolina, shown on the panel on the left. In Florida, barrier islands occur on both coasts. On the west coast is shown around Tampa Bay in the middle panel, and along the east coast as shown on the right panel. Barrier islands, because they are so low and sandy, are especially vulnerable to storms which bring large waves ashore. Consider the ways that these islands are affected due to increasingly severe storms. So let's start with the mildest storms. These have just a minor effect. The dunes may be slightly undercut as sand is removed and transferred offshore. These storms are common, and the features they produce, these small scarps cut into the dunes, are a common sight on barrier islands throughout the year. Here's an example from Fort DeSoto Beach in Pinellas County, Florida. I took this photo in October, but it could have been taken nearly any month of the year because these kinds of features are common following any kind of storm. As storm waves increase in size, they have a larger impact on the dunes. In many cases, they may take a big chunk out of the dunes, transferring the sand offshore and damaging any structures that have been unwisely located on the dunes. When you see pictures of damage on barrier islands, this is often the cause. People want their home to have a good view, and the high vantage point of the dune offers an ideal location, except when a storm eats away at the sand beneath their house. Here's an example from Hurricane Jeanne in 2004 along Florida's east coast. The dunes here were heavily eaten away, but not overtopped. Unfortunately, a street had been built on top of the dune and it was destroyed. The wooden structures that remain were once boardwalks that rode the top of the dune and helped people across them, but there's no more sand beneath them anymore. It's all been washed away towards the sea. Here's an example from Long Island, where an unlucky homeowner found his house destroyed because it was placed on top of the dune. From a geologic point of view, the dune was doing its job. It was protecting the barrier island and redistributing sand toward the beach and offshore beach during the storm. From the homeowner's perspective, however, it destroyed his home. Here's yet another example where you can see how removal of sand from the dunes put several very expensive Florida beach houses in peril. The blue line on the graph is the pre-storm profile, and the red line represents the profile after the storm. The difference represents all the sand that was removed from the dune and moved towards the sea, and it caused the dune to shift landward. The next level of damage occurs when the waves wash over the dunes, and this is where things get really bad. When the waves overtop the dunes, they carry sand towards the backside of the island and deposit it there in large sand tongues called overwash or washover fans. Both terms are used. Washover fans are a natural phenomenon, and they're really not a problem unless structures are built back there. Then it's a problem. Here you can see the result of washover following Hurricane Francis in Florida. That big white blanket of sand in the lower picture was deposited during the storm. And it's a problem if structures are in the way. This condo found its entire first floor choked with sand caused by overwash, and its swimming pools had their water replaced with sand. Swimming pools make great repositories for washover sand and upended palm trees and any other debris carried by storm waves. Under extreme storms, storms that may happen once every several hundred years, Waves can be so high and remain so high so long that they completely scatter the sand that makes up the barrier island back into the lagoon and ocean, so that the island is no longer an island. When the water recedes, the island is gone. This is what happened to this island off the coast of Mississippi. This picture wasn't taken during the storm, it was taken after the storm had passed by and water levels had receded. Water has receded, but the island is gone. Here's what Dauphin Island, Alabama looked like after Hurricane Katrina ripped through it in 2005, after the storm. Notice that most of the island is gone. Most of it's been replaced by water. The sand that made up the island is gone. And here's another example following Hurricane Ivan in 2004. Only the tops of a few islands remain. The rest of them have been washed away completely. I hope you can see why barrier islands are often considered the most vulnerable part of the coast system, and why most geologists think it's a really bad idea to develop them. Because they are so low and so narrow, they are vulnerable to storm waves. But it gets worse. Because they are so low and narrow, they are especially sensitive to small rises in sea level. As this graph shows, sea level has been rising since the end of the last ice age, about 15,000 years ago, as glacial ice has been melting and adding to the sea, and as the seas have been warming and expanding. You can see that sea level has actually risen by about 120 meters. That's over 350 feet since the last ice age. And as you probably know, the situation is getting worse due to global warming. The increased anthropogenic warming is causing glaciers to melt even faster and the ocean to warm even faster, raising sea level even more. Well, one of the ways that barrier islands adapt to rising seas is to migrate toward the coast. As the coasts recede due to sea level rise, the islands migrate with them, keeping the width of the lagoon that separates them from the coast approximately constant. As this figure shows, this migration is accomplished through overwash, which transports sand from the front of the island toward the back. This little animation shows how this process happens as sand is being transported from the left side of the island to the right in response to rising seas. The two arrows mark the original position of the island, and you can see that with time the island is moving toward the coast, which is located off to the right. Notice that this really isn't a problem geologically. It's only a problem if people build stationary things like houses on mobile things like barrier islands. Then their houses get destroyed. And that's the problem with developing barrier islands. They're the most mobile and vulnerable part of the entire coastal system.